Anyway, we'll get going. So my name is Joe Grand.
I'm Zaz Brooks.
And we are back for yet another fun, entertaining session about Prototype This. So, I guess we should ask. Who has seen Prototype This, which was a TV show on Discovery Channel? Okay, so that's more than last time, I think.
Yeah, and it's totally awesome that people who haven't seen it have still come to this talk. So
yeah, why did you come to this talk?
You'll be excited.
Cool. So, yeah, anyway, Prototype This was a short-lived TV show on Discovery Channel. 13 episodes filmed over like 18 months.
Yeah, it was from start of pilot to end of shooting, it was almost exactly 2 years.
And so we filmed it in 2008, and it aired for a little while in the U.S., and then started airing all over the place, and then kind of disappeared for a while. Now it's revived itself on Netflix and Pirate Bay, which is awesome. So definitely check it out if you haven't seen it. And it basically was 4 guys building crazy prototypes of stuff. And we're going to talk about some of those crazy prototypes.
Yeah, and with not very much money or time. There was sort of like this artificial time limit that the network, made us do to sort of make it seem more exciting, even though often we took more than that time. And they kind of forgot to budget for engineering supplies, and that's serious. And so they managed to cobble together from the budget $12,000 per episode for all engineering supplies, consulting, everything.
Yeah, which is not a lot when you realize that the show is about engineering. And so if you want to know a lot of the down and dirty secrets of the show, see our DEFCON 17 talk. And same production company as Mythbusters. Somebody the other day was like, "Hey, you guys should talk to those guys that make Mythbusters because they made an awesome show, so they could do another one." And I'm like, "Actually, we did." And our show was awesome. It was just 1 season. So, so the original fan site is still up on the Discovery Channel website, and then all of the engineering documentation that I could gather for the technical portions of the build, the electronics portions that I had handled, and then the software stuff that Zaz has done, is up on my website. So if you want to build upon it or use it or see how we did it or just grab the code or whatever, you can. So here's the talent. That's what they called us, talent, which is kind of cool. Let's see.
We didn't get a dressing room, though.
No, we did not. We asked for one here, though, but they didn't give us one. Anyway, so I was the electronics guy, as I said. Zaz?
I mostly took care of anything that needed to be coded for the show, and also late-night machining.
Yeah. And Mike North was our man of many talents. He didn't really have a defined role. He sort of just did all the stuff that nobody else wanted to do. And then Terry was our machinist and special effects guy from LA. So it's kind of a good mix of skills across the board. And the show originally started, the production crew was like, let's just put some cameras in a room and, go build something. And they didn't realize there was a whole process behind the engineering and design and testing and failing and fixing it and all of that. So it was
I shit you not, on the pilot, they literally put us all in the room with cameras to design this robot, and they said, all right, guys, start designing the robot. And then they got bored after 30 seconds as we started actually doing real design. They're like, all right, just throw some things in a pile and say that's how you're going to do it, and then we'll leave you alone to do the real design meeting in a few hours.
Yeah, and then what made us feel great is we had a separate room. So the machine shop was in one place. We filmed the pilot in a place called Tech Shop in San Mateo.
Menlo Park, the original tech shop.
The original tech shop. So it was, there's machines and lots of stuff to work on. So the machine shop was in one area. We had a room that we had called the lair, which was our electronics area, and all the machines set up and stuff for soldering and coding. And we were in there building some stuff for the pilot. And the camera guy, who I guess was a famous camera guy and filmed National Geographic, amazing whales and oceans and stuff. And he was filming us soldering, and he's like, okay, this is boring, I'm going. And then he went into the machine shop and just hung out and smoked cigarettes or something, or did coke. The first few people we had on our show it was really bad.
There was some production problems early on.
Yeah, but these people that are up on here were not doing coke, as far as I know, and it was very helpful. So the 4 of us were on screen, but we had so many people behind the scenes helping us, and that's always this myth with television is oh, you guys have your own show, you can do whatever you want, you could whatever. But there's so many people that were helping us along the way. So, PAs and production staff and various producers and stuff. And we definitely wouldn't have been able to do the show or the builds without them.
Especially Joe Andreas, middle center, who's a special effects guy from down in LA. And he's just a total maniac, can build anything. And he was spending a lot of late nights on some of the later builds. Once it became clear that the show was so difficult to make, he got brought in for a lot of episodes, and you'll see some of the stuff that he did when we get to the builds, which we should get to.
Yes, we probably should. Yeah. Okay, so who is here for our DEFCON 17 talk? Okay, a few. Cool.
And who's here at DEFCON for the first time?
Oh, geez.
Nice. I hope you're having a blast.
It's like half the people here. Okay, so last time we talked about, I can't see the slides sort of, but traffic busting trucks. That was the upper right. It was a big giant truck that elevated itself and drove over traffic and had some autonomous modes and crazy things like that. Firefighting pyro pack. So this was a high-tech pyro pack for firefighters that had a heads-up display and a thermal imaging camera and some sensors for firefighter identification and an awesome superhero dry chem thing that Zaz had made. Like you pull this thing on your arm and chemicals come out. Right?
Yeah. Watch the show. Let's get to the next slide. Let's talk about what we're actually talking about.
Sea adventure, water slide, flying lifeguard. Here's what we're talking about. Go for it.
Yeah. So today we thought we'd cover our other 5 favorite projects from the 13. Boxing robots, what Discovery called mind control car, 6-legged ATV, the get up and go sleep pod, and autonomous pizza delivery.
Yes, sir. All right, so boxing robots, this was our first official build. We had filmed the pilot, and none of us knew each other. And a few weeks later, we started building these giant 10-foot boxing robots that would move based on the movement of players outside the ring, and we made this whole spectacle around it.
Yeah, basically this one was Terry's idea. We'd gone through the pilot, and originally they wanted us to build 2 completely different things per episode. So it was even harder to begin with. And so once we got through the pilot and everyone was kind of fried already, Terry was just like, let's do giant boxing robots, because we all know how to do it. Terry's done all this kind of special effects stuff. He basically had the whole thing in mind mechanically already, and we knew that we could figure out the electronics and the code pretty easily for it.
And this one, I think, was actually a 2-week build.
Yeah, this was one of the few that we got done on time.
Let's see. So, yeah, this... Oh, you can talk about the mechanical stuff. I don't really know what it is. I don't understand it.
Well, basically, everything was super simple mechanically. It was just sort of universal joints welded together with pneumatic cylinders to move everything around. And then the outside, this is one of the things that Mike contributed. He's like, we really need to make these robots look awesome, but we don't have time to even really think about the exterior design that much while we're building the inside. So I know this guy. He's really tied into the San Francisco art scene, Burning Man and everything. He's like, I know this guy who builds robot sculptures out of found stuff from junkyards. So let's just get him to select some stuff to put on the outside. And Nemo came in and just made these like totally awesome looking, badass robots out of bits of cars, and the heads are made out of
gas tanks.
They're the outboard motor tanks for a boat, and so it'll end up looking really cool.
Yeah, those look cool. And it was the robots were pneumatically controlled, so that was just this Pro XR serial RS-232 interface. So Terry kind of handled that build of the robot side, and then Zaz and I handled the detection and control of them.
And Mike actually built the second robot, but they didn't film it because they wanted to make everyone like sort of pigeonholed, and so he just got totally ripped off and no one knew. But he built the second robot.
Poor Mike. Okay, so let's see. From the hardware side, we needed a way to detect the punches that a player was throwing, so we decided to have 2. It was the jab and the uppercut. Mm-hmm. And we used a Freescale Z-Star module, which was this 3-axis accelerometer reference design. They don't make that version anymore, but they have some other one if you want to mess around with them. There's a cool software interface that we could see the actual results, and it was graphed. And that's how we figured out we would throw our jabs and uppercuts and figure out how we were going to detect those.
And so I can't see what we've got here. Oh yeah, so I had to do it in Windows because of the cameras we were using. I wanted to get some nice high-res Firewire cameras, but the budget didn't support it, so I ended up getting these nice IDS micro eyes. They're USB 2, sort of like a webcam package, but it's an industrial sensing camera, and they were pretty nice for detecting. And then I just used an AR toolkit build to do the motion tracking. So that was like super simple. Basically out of the box, you get the 6 degree of freedom information from the glyph. And then for the punch detection, a pretty simple shape filter on the 3 different axes. It turns out that if you throw a jab versus this uppercut thing, you get a pretty nice repeatable signal from that every time you do it. So it was just like a little filter on that. What else is there? Yeah, and then those classifiers did was send out punch packets basically to the pneumatic controller. So I would assemble a cue, feed those out via UDP, and that becomes important later. Oh, wait, I'll say it now. That side. So people asked afterwards during the final battle. They were like, "How come your hands were on the keyboard the whole time? You were just cheating for Joe, right?" And the reason they were is because like anything, when you just coded pretty much the day before, there's still some issues, and we hadn't really done a lot of testing. So I was able to fill up the motion queue of the robot, so they had a few punches left to go, and then I could quickly kill the program and recompile and bring it back to the status that it was on. So I had a few hidden keys to bring the score meters and everything back to where they were when I had to kill the program during the fight.
It's the magic of television. And I think this was actually the first television usage of AR toolkit, right, of augmented reality?
It seemed to be really new. I'd seen it at a conference a little while before that, and everyone, a lot of the people that I knew were using it, but when I told the TV guys about it, it completely blew their mind, and they couldn't understand the way that this glyph translated to something moving on a screen. And I had to eventually build this little ball maze, which I control with a glyph. And those TV guys like, "Oh, right, okay, finally we get it. All right, cool."
And then they ended up breaking it by accident, right? Yeah. So besides the control of the robots, which mostly was software-based, we also had what we called the healthometer, which was a scoring system, because we actually had a whole set-up boxing match. Oh yeah, I should mention too, so the boxing match was supposed to be like nerd versus awesome boxer. And since this was the first episode, they're still trying to pigeonhole us. And we trained we went to a gym, an actual real boxing gym in San Francisco, and got to fight a Golden Gloves national champion or something that, she was about this tall, a female, very scrappy. And, you'll watch the episode, you'll see.
But basically, it was all like, let's see the nerds get beaten up by a girl, and that's it. Everyone's going to think that's funny.
It was awesome.
Which it was kind of funny.
Yeah, well, yeah. But so we needed a scoring system. So the healthometer was sort of an independent thing that we had magnets and Hall effect sensors in the robot's neck. So as the robot got punched and the head would go back, we would detect that as a hit and then reduce the score. That was a basic stamp 2, and all of the lights were just 120 volt, colored floodlights. So we had this. We had a bunch of SSRs with an EFX-Tech RC4 controller, which can control 4 solid-state relays over serial. So we had a bunch of those. You could just send commands from the basic stamp when you detect a hit, then we could change the score. And I should mention, too, that people are probably wondering, why basic stamp? How come not Arduino? This was in 2008 when Arduino was not even, sort of coming up. So, you could do these same sort of things with Arduino if that's your platform of choice, and you can check out the code and sort of port stuff over. Oh, yeah, here's a video of it. Is it going?
No.
So they're punching and stuff. It was more exciting in person.
At first, because we'd made all these nice, painted gloves and the legs and everything like that, and we didn't want to destroy them immediately. So at first we had to turn the pressure down on all the pneumatic cylinders, so it just kind of worked. And then in the final battle, we turned it up to maximum, and bits were flying off everywhere. Yeah.
Oh, and the other thing too is don't let an animatronics guy script up custom things to do with 2 robots up on stage. I have videos of those, but I know there's some kids here that are under 18, so I'm not going to show it. But it looks strikingly real for 2 robots. It's it's crazy. Okay.
All right. So this was the one that the network decided to call Mind Control Car, and what we called it, this drove me freaking crazy, so this is a rant. We called it anger management, and the idea was that if you get road rage, then a therapy session would be to have to participate in a demolition derby where the angrier you got, the worse your car would perform, right? So you'd have to learn to stay in control while you were trying to smash other people's cars. And then the network, just either didn't get it or didn't, they were trying to push everything as being this future product. And so they said, when you watch the episode, it says, in the future, when you get angry, your car would pull off the road and stop.
Because that won't make you more angry.
Everyone who watches the show is like, dude, that's so stupid. You guys are idiots. Like, who would want a car like that? We're not fucking stupid. Yeah. It was never about that.
And they showed it over and over again, that cartoon. So actually, this episode was an exercise for us in anger management, too. I'm not going to get into the whole story. We'll just say that both of us almost quit every day. And you almost got kicked off the show, right?
Yeah.
For your hair? I don't know if it was your hair or if it was something else with that other person they tried to add on the show. Yeah, it was this was like a miserable experience. It turned out okay, though. So this was 4 cars, remote controlled, that would crash into each other, and you had to stay calm. And it also took GSR and EKG as part of other things to monitor in your body.
Yeah, we're doing this whole kind of biometric thing with the the measurements of heart rate and galvanic skin response to see if people were stressed. But of course, the big deal, which we'll get to in a sec, was the sort of mind control headsets. Yeah. Just wanted to quickly say something about instrumenting or automating a car and making it remote controlled. We wanted to ask the guys from Mythbusters about it because they've done it a million times and they would just tell us what to do and save us a lot of time. And the production company was like, no, you cannot talk to those guys. We want to keep you completely separate because we don't want it to look like you're a Mythbusters ripoff show, even though we're basically trying to do, have the same success we have with Mythbusters. So we got Joe Andreas in and he figured out how to do it all. And it basically is really simple. I talked to my brother as well because he had some guys who had done robotic cars. And if you want to make a robot drive a real car, there are some serious issues with it, that you have to deal with, like stiction in the pedals and things like that. And there's a lot of complex control stuff. But if it's just a human driving it, they just figure all that stuff out. So it's just super easy. You can just see it's almost totally ghetto. There's a motor with a cam on it that's pushing the pedals. The steering wheel's just connected to a belt drive. These are total beaters from the junkyard, right? So it's not like doing a Prius where there's already motors in the power steering and stuff. And then there's not a photo of it, but in order to shift into gear, there's just a big fat linear actuator on the gear shift, and it just...
And so, yeah, we had to do this for 4 cars, and it was all... originally, this was, since Joe Andreas does a lot of special effects stuff, it was all just RC transmitters, which Zaz had to actually get hooked up to his PC, which I'm sure he's going to enjoy talking about. Okay, so from the electronic side, we wanted to have a pod. Each person would have a pod that they would sit in, and they'd be hooked up to all the stuff, and they'd have a screen, and they'd be able to see what their car is seeing. But then they'd also have this heads-up, or this on-screen display of their current heart rate and their I don't know what else is up there. Oh yeah, what gear the car is in, the acceleration, and all of that stuff. So they had to calm themselves down.
And we were actually worried that, because it was the 4 of us driving and we knew the system, that we wouldn't get angry enough and it would just be kind of a bust and the cars would just always just work. So we also designed in that Joe figured out how to do an electric shock machine that would
shockerator.
We had to send shocks to each other while we were trying to drive, but we didn't end up using it.
No, we used it, just not on the show.
We used it on Mike North.
Yeah. And we did find some way to cheat on this game, didn't we? Didn't I win?
Yeah, no.
I think I don't remember.
I think you did, but I think it was because everyone else's car died.
Oh. No, it was if you took off the emotive headset, which we're going to talk about for the mind control part, or something like that, you could sort of cheat it to still move around, it wouldn't stop you. Yeah. I don't exactly remember.
The mind control was only to get the car started, and then you could also shut it down. But yeah, if you moved the electrodes, I remember now, so that they didn't get a good reading, it would just kind of freeze out, and then the car would keep working forever.
So the way this worked is I had a PS2, PlayStation 2 driving controller that was just regular PS2 connector. Hooked that up to a basic stamp because the PlayStation 2 controllers are all serial, so I could monitor that and pass those commands off to Zaz over network. So I was using Lantronix export, which are serial to Ethernet adapters.
They were basically the coolest individual component of the whole experience.
We used those a lot.
Being able to not deal with serial anymore and just do everything over the network was just so nice.
Yeah, it was nice. And then the Bob 4H on-screen display, which was also a serial type of device. You send commands to it and feed video in and get video out, which was kind of cool.
So the big deal, though, for everyone at the network was these new, at the time, mind-reading EEG-based headsets. And so we talked to the 2 companies that were at the time working on the prototypes. One was this company Emotive, and it's a single electrode device that you've probably seen it now in a lot of products like the Star Wars Force Trainer. And if anyone wants to do any hacking of brain-machine interface stuff, this thing is super, super easy to do. All of the EEG-based classification takes place on a custom ASIC, and then it gets fed out over one of the lines on RS-232 at like 9600 boards. So you can just tap in and you can get everything from that chip. So just take apart a force trainer and you can use it to control all kinds of things. You get, I can't remember, you get two 8-bit values out of it. The one is, we get 3. One is like how well the headset is making a connection, and then you get 2 useful ones, but you don't really know what they are. It's like whatever I set up there, which I forgot what it was. Attention and meditation. And so we weren't really sure what either of those things were and whether they really related to road rage. And anyway, at the time, we think they only had a couple of headsets and they couldn't give us 4 of them. Yeah. So Emotive had this one that was also new that was a video game controller that had 10 electrodes and did, in addition to these kind of like calmness measures, it would read the electrical signals from the facial musculature and give you facial expressions. And then also it had this kind of classifier, which they wouldn't tell you how it worked, but you trained it. It was probably some kind of support vector machine. So you would think about something while in training mode, and then if you thought about that thing again, it would recognize it. And supposedly you could train it with like 10 different things, but no one, even at Emotive, said that anyone at that point had been able to train it with more than like 2 or 3. So we just decided we'd go with that one, and we would use with the mind control thing because it was sexy and new, and think about something to start the car. And to show that off, we did the good old spoon bending test.
Yes. And also this... the Emotive, I think it's the Emotive, or there is another brain-machine interface thing for toys. I think it's a Mattel Mind something game where you control a ball. And yeah, people are starting to hack on that now. What's it called? Oh, it's NeuroSky. Okay, so the NeuroSky one. Okay.
Yeah, so that's in a lot of different products now. If you pull them apart, you can see that little chip.
Yeah. All right, so here's the spoon bending test. Actually, I'm going to have to hold my mic up to the speaker, I think.
Well, we can... Here's how this test is going to work. No.
Lame. Okay.
Well, never mind. Anyway, a lot of our sort of attention came to how to demonstrate technical stuff so that the TV guys could understand it, and so that then people watching the show also would think it was fun and cool if they didn't already know about it. And so, Joe and I ended up spending quite a lot of our non-design time thinking about ways that we could get technical stuff on TV. It was really a fight with the production company. So once we're like, well, mind control, what does everyone want to do? There's that Uri Geller guy, bending spoons. Let's bend the spoon. And then similarly, this one I was really proud of. Like out of everything that we did for Prototype This, one of the sequences that I'm the most proud of is I managed to convince the network to let me talk about multi-threaded coding on national TV, right? So we filmed this little, what Joe and I called them was like podcast-style segments. And once they had basically come clean to us and said, look, we're not going to talk about the nitty-gritty details of the stuff you guys do because we think it's really boring and we don't understand it. So we would come up with these, they said, okay, you can have 1 minute per episode to do a podcast-style technical introduction to whatever it is that you guys do. And just to illustrate that this was so serious, in the Mind Control Car episode, Joe had designed this whole circuit board to control the pods and everything like that, and they didn't show it in the episode at all. The most important thing that Joe had done, and the reason was the network execs didn't know what a circuit board was. And afterwards, when we were really upset about it, Joe was like, what the hell, man? You just cut all my stuff out.
Yeah, every single episode has a circuit board and they don't know what it is.
Yeah. And then someone, I think John Tessier, explained to the network guy that a circuit board was the green thing inside a VCR that made it work. And then they're like, oh, right, okay.
We got to show that.
We'll show that.
Yeah, so we actually have on one episode we go to watch circuit boards, getting fabricated for one of our builds, which was awesome. But yeah, so making technical things look fun and sexy is really hard. If you're in this room, you probably would just, we don't need to make it fun and sexy because you already think it's fun and sexy, but like for my family, had to make it fun and sexy. So okay, I think we have audio now. So let's try this one. This was the multi-threaded.
Yeah, when I scripted this podcast style thing, I was like, we're going to do a 4-way split screen, and Joe is going to be each of the threads. And the producer was like, that's total chaos, man. Like, it's going to take us all day to film this. Come up with something else. And I'm like, no, this is going to be really cool. Trust me. And so I'm really proud of it. So I wanted to show it.
Yeah. All right, here we go.
An inside look at computer coding.
Right now, Zaz is coding. It might look like he's just playing around on the keyboard, but he's actually writing specialized programs that are going to tie all of these different parts of the build together. It's pretty complicated stuff. So for a little better explanation, some more detail about how everything really works, I present to you the Codemaster.
There's a lot of custom code that has to be written to get this anger management system to work. That's why you see me typing all the time. Code is a written set of instructions that tells a computer what to do, and I'm the one that has to write it. My code is made up of threads. A thread is like a little program that runs inside a larger one. There can be a bunch of threads, like Joe here, but they all run independently to perform a specific task. In this system, each car is controlled by 4 threads. A game controller thread, which takes data from the steering wheel and pedals. A biopack thread, which reads the driver's heart rate and perspiration level to regulate the car's performance. An emotive, or mind control thread, which controls the car's transmission. And a car controller thread. So let's say the driver puts the pedal to the metal. A signal gets sent to the game controller thread, telling it to hit the gas. At the same time, the biopack thread is also getting data from the driver's body, measuring heart rate and perspiration or galvanic skin response. At the same time as this, the emotive thread processes events from the emotive system and decides whether or not the car should be put into forward gear. Finally, the car controller thread looks at everything the other threads have produced and decides what to do with the car. If the driver's brainwaves are calm and focused, and their heart rate is good, and their perspiration level shows they're cool and collected, the car controller thread puts the car in gear and hits the gas. But if the biopack and emotive threads show agitation, then the car controller thread will slow things down because the driver's getting too stressed. This is all just for one car. For 4 cars all working together, that's going to be a lot of threads. And if I can't get all those threads to work together, we're going to be dead in the water.
So I had to re-record that voiceover about 12 times because they wanted to tweak things like, we don't know what the emotive thread is, you have to say emotive or mind control thread. And also they, of course, made me say that thing at the end like, yeah, if I can't get it to work, everything's going to be screwed up.
Oh, doom.
I designed it, of course I'm going to get it to work. But they have to add the drama.
And so I don't have a picture of the actual demolition derby because you can go watch it on your own, but this is like a behind the scenes of us testing it. And I think, our producer is driving it. John Tessier is our producer. And there's nothing more scary than seeing a car drive without a person in it. Like, it's going to be cool, but when you're sitting in front of the car and it's driving on its own, it's terrifying. So here's a demo of that.
I guess this is the case with all electronic systems, but you just don't think about it when it's not something you've hacked together. But you just like when you see something like this, you just know at any moment something could fritz out, and the accelerator goes all the way down, and this thing just like makes its way into the bay, or us.
Yeah, so that one was actually pretty cool. The 6-legged all-terrain vehicle, the bane of our existence.
Yeah, this one I don't know if I should spoil it, but anyway, it was a hard project that may or may not have worked in the end.
Yeah.
Basically, the idea was, we wanted to build some kind of crazy contraption that a person would ride in, and we thought about, a legged vehicle. So, building legged vehicles is tough, right? Some of the smartest guys that have ever worked on robots are working for companies like Boston Dynamics to make legged vehicles, and so we're not going to get it done in 2 weeks unless we start with some kind of small robot platform and just scale it up. So that's what we decided to do right off the bat, and then it was just a question of which one. We looked at a few that we thought would be fun and cool, and the one that we chose was this one called Rex, R-H-E-X. And it has the distinction, I think, for being, in terms of body lengths per unit time, the fastest legged robot out there. So we thought that would be cool. If we can scale it up, we'll have the fastest legged vehicle out there. Yes, so we should make sure we have a crash cage so that the driver might survive. And so we got this guy. The Rex project was actually at several universities, and the licensing for the Rex, like a lot of the Rex patents, was licensed by a guy called Haldun Komsuoglu, and he started a company, Sandbox Innovations. And he came on the show to help us out and tune all the controllers. The interesting thing about the platform, it's got 6 legs, and they alternate in tripods. So 3 of the legs come forward and take the weight of the robot, while the other 3 flip around. 1 degree of freedom per leg. So these legs are just flipping around.
And that's actually, it's a biomimetic thing, so it's based on, what was it, like a cockroach or some bug. We had to go visit some disgusting
it's
one.
inspired, the alternating tripod gate, if you look at hexapod creatures, they all do it. Roaches actually do some interesting stuff with their back legs when they move really fast, but mostly they walk by 3 on the ground to maintain stability. And just the interesting thing about this one is, when the 3 legs come in and take the robot's weight and the other 3 whip around, the materials properties of the legs are super important. If the legs are too stiff, then the robot just stays in place. It depends on that springiness of the legs compressing to take the weight and then bouncing the robot forward to give it its speed. So that's why designing the legs, off the bat, we thought that was going to be the toughest problem, and we really concentrated a lot of energy in the form of Mike North on those legs.
Yeah, and also scaling something up isn't always just as easy as scaling something up, and the legs were part of that problem. What you want to talk about this mechanical thing, legs?
Well, anyway, I'll just say one thing. We went out, at this point in the show, we were able to get outside consultants to help us out, and we went to Spec Design to do the design of the chassis. And the guy from Spec, their lead mechanical engineer, super nice guy, and he was really, really concerned about the safety of this thing. I mean, you see that video and you know that basically no good can come of this. So he was very resistant to using aluminum tube for safety reasons. He just wanted to make this thing just built like a tank. So we ended up going with chromoly steel, which caused big problems later on because it was so heavy. I think you could do this safely out of aluminum if you just you did a bunch of FEA on it and you just figured out its crash scenarios and just making sure that structure wasn't going to break. But there wasn't time for that. But props to John from Spec for caring about our survival.
Yeah, and we didn't build that chassis at all. We had some other guys build it outside who specialize in making chassis. And then the legs, Mike North helped design them, but they were made by a place that specializes in composite, making things that out of carbon fiber materials. So this build we definitely would have been able to do by ourselves. No way.
And they gave us a whole fridge full of carbon fiber composite and so on, because you had the cement you have to store in a fridge, and they just delivered it. So those legs probably would have cost hundreds of thousands. I don't know. It's a lot of carbon fiber.
Well, that's the benefit of being on TV. You just call someone up and say, "Hey, we're doing a TV show. Can you give us some free stuff?" And they'll be like, "Sure," until they find out what it is that they're doing. And but yeah, they committed a lot of money to it and a lot of resources. It was awesome. So Mike got these legs back, and he wanted to demonstrate how springy they were, because the springiness was the important part of this project. So he built this whole contraption to ride a horse. I guess he's from Wyoming, so this was like a natural thing for him.
So that's our omnidirectional forklift. I'm driving the forklift, and I'm just jacking it up and down to put some oscillation on that leg. And let's take a look at what happens.
Yeah, check this out.
The leg is very strong and pretty much unbreakable, as you'll see.
I'm not sure that made it to air.
Yeah, that gave a lot of the TV people the brown trousers, because they didn't have a lot of liability insurance for this kind of stuff. So that footage, if Joe didn't save that, then that would never have seen the light of day.
I think that stuff actually disappeared from the reels, from their tapes. So Saz and I had our ways of getting some of this important footage to preserve history. The drivetrain.
Okay, so just a little bit about this. When you scale something up, especially when you only have 2 weeks to do it in, the big decision really is how far out of your comfort zone do you want to get? And we were trying to decide whether we should go, the little Rex uses brushed DC motors with planetary gear heads, just like these Maxon, nice ones, but things that we're all really familiar with. The Boston Dynamics, like Big Dog and stuff like that, has a hydraulic drive system. And then we could have gone somewhere in between, like some of the, if you look at amusement park rides, they have these giant three-phase electric motors and stuff on them. So, we're just trying to toss up, should we go hydraulic? We've never done anything really with hydraulics before. Should we, go to these other systems that we don't know a lot about? Or should we just try and scale it up, And we just said, all right, let's just, we think we can do it. We've done all the torque requirement calculations and stuff. We think we can do it just with brushed DC motors and planetary gearboxes. In retrospect, that was a mistake. We should, if we were building this again today, we would go hydraulic, because that would just solve a lot of problems. You could just throw a ton of pressure at the problem. But what we decided to do was get these, sort of go the BattleBot style route with it, get these custom wound mag motors that are really, really high performance, just a huge fat industrial planetary gearbox on it with a 40-to-1 reduction, and we think it'll work out. The motor things started to not work out pretty soon. The motor controllers we had, even though they said they were rated for the currents that we were putting through this, it started to explode pretty quickly, and they had all these safety features in them, so that would just turn them off. So the machine would try and stand up, all the safety things would kick in, and the thing would collapse. So we disabled the safety features, exploded the motor controllers. We went out there to find the beefiest DC motor controllers we could find, and what we got were these DEFCON millipacks. They're for electric vehicles. So we put a whole bunch of those, one per leg. Then we started to discover, we know that we can do this, but this machine still won't stand up. Like, what's the problem here? And we figured out when we talked to this guy, Peef, that when you run 1,000 amps at 48 volts, right, 48 kilowatts through a wire around the outside of a chassis, even though it's a single loop, inductive effects start to come into play.
It was scary shit.
Yeah, and you can't get those rise times that you need if you want to just turn it on. So, we had to strip down, rewire everything, just get the slightest loop out of it to get rid of those inductive effects.
Yeah. There's a lot of noise, and we made an optical, essentially like an optical communication system. So it was taking in the motor control signals and then sending it over fiber optics to the receiver, so we could get rid of all the noise that was being caused around the system.
Yeah, these giant 48 kilowatt EM pulses were fritzing everything out. So when you build EVs in the future, if you're gonna do that, go high voltage and keep those currents down, because they're a problem.
Yeah. Oh,
let's skip the
leg
video, 'cause I think
attachment
we're
is
going
this.
slow.
Okay, we'll skip the podcast. So the control side, we needed a way to drive this thing, and the original version that Halden had worked on was I think he was controlling it just from his Linux box, but we wanted a real joystick so you could sit inside the chassis and control it. We had a bunch of buttons that would stand up the thing, and we tried to stand up the thing, have it sit, and change the different modes. So it was sort of an arcade style thing where you would sit inside the chassis. So I had a PC, this was an arcade style joystick, just a big, huge arcade style joystick with a modified board that I'd worked on. So I had a project called the Stell Adapter, which was this Atari 2600 to USB interface that you could use paddle controllers and joysticks and stuff. So I modified that to be the big joystick to USB interface, and then plugged that into Halden's control box, which was some Linux machine. And then we had a trigger that just served as a dead man switch. So it was actually kind of cool, and it worked out pretty well. The batteries we used,
they were exciting. Another chance to use something that at the time was new. So these were these giant lithium iron phosphate batteries from China. So that was a pretty much brand new chemistry at the time that everyone was excited about. The thing was, they were so new that they didn't come with a battery management system. So, we're halfway through this project, and suddenly, hey, Joe, you got another thing to design. Design a battery management system for these brand new batteries that you can charge with an inrush current of 72 amps?
Yeah, they could charge at a very high current. But yeah, I think we got the batteries first, and then they're like, well, how are we going to charge them? And they're like, Joe, hello. So we had to design this thing. We had one day. We had one day to design this. So this was a time where we reached out to some of our contacts and begged to have our boards fabbed right away. And we actually got the boards fabbed and got them back the next day, which was ridiculous. So for each individual battery cell, which was this lithium iron phosphate, it had similar properties to like the lithium ion. So I could use a Maxim, off-the-shelf Maxim lithium ion charger and just jack that up to the max that I could. So it was a 4 amp charging rate, which is slow. Like that's good for like a cell phone or some portable device, but not gigantic batteries that had, I think it was like 90 amp hour batteries. So it took 15 hours for full charge, which means that production actually had to plan ahead for our builds. Otherwise, we'd run out of battery power. But it was cool. So it had a charging circuit and also a discharge, because you don't want to run lithium ion types of chemistries below 2.7 volts or something like that, 3.0 volts. So I built a little discharge circuit, and the LED would be green when you were above the right threshold, and it would turn red when it wasn't. So we could easily just look at the system and see. So it was sort of a totally hacked together budget battery management system. And normally they cost like thousands of dollars for electric vehicles or something. And yeah, we cranked it out. This is your favorite, I think.
Yeah, so this was a fun episode for me because I got to be the test guinea pig, and all kinds of just terrible indignities were wreaked upon me in the show. But the idea was, you see those old cartoons, like the Warner Brothers cartoons, where someone, is in the future, and someone just jumps out of bed, and they go on the conveyor belt, and their clothes get stripped off and washed and fed, and we wanted to see, well, could we really build something like that? That you would sleep in, and it would give you a good sleep, and then in the morning, it's going to force you to get up. It's going to strip your clothes off, shower you. We looked into automated feeding, and then it's going to give you your clothes, get dressed, and you're going to get out there. One thing that we actually did have a lot of discussion about the Get Up and Go behind the scenes, and we're trying to figure out how to do it, is the first thing you do when you get up in the morning, you take a piss, right? Everyone knows that. So how are you going to do that in the pod? And we're talking about like having like a urinal pop up and but of course Discovery decided that on TV people don't go to the bathroom.
Right. And also you can tell that nerds built this because only one person sleeps in it at a time. Yeah, so this was actually, we had a real hard deadline for this one, and this was scary because we were debuting this in Union Square in San Francisco, which is a pretty serious, kind of touristy spot. So we had this whole thing kind of pushing it like a tele commercial, whatever, buy this now as, TV.
Like those pitchman things.
Yeah.
Terry put on his white coat and was trying to sell it to the crowd in Union Square.
It was pretty bad. So the system, the hardest part of this was fitting everything inside. There was a HVAC system, and let's see, what else do I have on here? We have a machine that Zaz had that would control all of the pneumatics. Again, we had a basic stamp to control. We had some optical encoders, and we had some lights and LCD and a user interface, and just a lot of crap in there that we had to fit in that was never actually shown, right? So it just looked really cool, but there was all this stuff inside.
Yeah, turns out, especially the HVAC system, we got this super cool little compact one. I don't know if it was supposed to be for like an RV or something like that, but we had to put that in there, plumb all the air around. The water supply was off-board, so we managed to sort of cheat a little bit for TV for that.
Yeah. Let's see, so the basic stamp, we had an optical encoder to detect, to control to know where this shower tray was. Another export to communicate with Zaz's stuff. So at this point, we sort of had a system where all the control stuff would just be sent over to Zaz, either serial or network, and then he could do all of the heavy lifting for the stuff. So it sort of worked out that way. Here's the user interface.
Yeah, so I got lucky. I had a friend who was working for Color Kinetics, and I said, can you send me some Color Kinetics lights sort of under the table? And so he sent me a bunch of these iColor coves. And at the time, I don't know if the situation has changed, but at the time, Color Kinetics was just being really bitchy about releasing the protocol for talking to any of these things, and people were having to spend a lot of time reverse engineering it. So I just said, look, man, can you just tell me what the protocol is? I promise not to tell anyone. And so he hooked me up and gave me the Ethernet protocol for the Color Kinetics lights, which is really nice.
Yeah, it was like Ethernet to DMX 512, I think, which was a standard.
That was
lighting.
one of them, but yeah there was those two protocols. And then the whole thing was actually controlled, just by a Mac Mini, by the GUI on the side there. So it wasn't all automated. There was just a nice little control thing that someone could use. So when we actually demoed it, Joe was off to the side VNCing into that Mac and then controlling the GUI using that. So it was total Wizard of Oz man behind the curtain.
All right, so here's what happens. Here's a demo. So that's our producer giving it a test ride as the thing closed. So we don't have a full demo of Zaz getting showered and stripped and everything, but I know you guys want to see that.
If you're really into that, you can download the show.
Yeah. All right, so the final build that we're going to talk about is the automated pizza delivery, because everybody loves pizza, and no one wants to actually go out and get it. It's a pain in the ass, so why not bring it to you?
So the backstory behind this one is that the network exec in charge of Prototype This had gone to a Brookstone or something. He'd seen the SkyMall catalog, and he'd seen one of those little silver helium remote control blimps in the SkyMall catalog. And he said, you've got to have the guys use that to deliver pizza. That's going to be totally awesome. Put a pizza on that blimp and deliver it. And we said, that's a stupid idea. That little blimp cannot carry a pizza. And he's like, no. You got to put the pizza on. You've got to put the pizza on. It can do it. I'm sure of it. We're like, no, it can't. He's like, how do you know? Have you weighed the pizza? So finally, we're like, all right, we're going to do this. We're going to figure out a way to do pizza delivery automated. But he just insisted on the blimp. So, he forced us to get in one of those big blimps that they have at the stadiums, throwing out T-shirts and stuff like that. And we had that carry a pizza. And then we went to the Goodyear blimp, and we threw pizza out of the windows of the Goodyear blimp. And just basically to be like, leave us alone. We're going to do this, but not with a goddamn blimp.
Yeah.
And because of this whole weighing the pizza thing, every day Tessier would get an email, have you weighed the pizza yet? So just to kind of like, stick the knife in a little bit, we filmed this sequence of weighing the pizza.
Yeah, and working on this show is like working at any other corporation. You have a bunch of dumbasses up here with stupid ideas trying to tell you what to do. And being hackers, that really sucked. Okay.
So here's weighing the pizza.
Yeah, this is weighing the pizza, and yeah.
Whenever you do a prototype with a blimp and a pizza, sooner or later, you gotta weigh the pizza. I got my scale, and I got a pizza. Fresh out of the oven. Commence weighing the pizza. 3.51 pounds. Gentlemen, I've weighed the pizza. 3.5 pounds.
So that's a total prototype this in joke, and now you get it too.
And the guy approved it on the network. I don't even think he knew we were making fun of him. So there are two different versions. We had a robotic version for city streets, and then a vehicle for longer distances. And this would have been cool to use like a DIY drone sort of thing, quadcopter, but there wasn't accessibility to that yet. So the automated, we had a pizza pie pack. So for both of these systems, we needed a way to autonomously give you the pizza once it got there, right? So we had a credit card based system, this crazy wired up just by hand basic stamp. We had an LCD, mag stripe reader, keypad to enter in all your infos, and motor controllers and optical detectors for the pizza tray. And it was cool. Here's sort of like, we have to build a prototype before we build the real thing. So there's Zaz demonstrating the pizza pie pack. And then that's one of the final versions of the robot version.
Yeah, so that robot on the right is we hit up our contact network, and I didn't have to go very far for this one because my brother started a company called Marathon Robotics. They're doing really, really great, and they make live fire sniper target robots that are completely autonomous. They're I think this is what he's told me anyway, because the U.S. Marines bought some, and they're officially the first autonomous ground vehicles to be deployed with the U.S. Armed Forces. So here it is.
Yeah, here's
if
a
you
video
look
of one
closely,
getting shot.
this is my brother making fun of me, because if you look closely, he's wearing my signature T-shirt on that robot that just got shot in the head. So I don't know what he's trying to say there. And the robot, after they get shot, the other ones all scatter and hide because they know that the first one got shot. So they're these super cool targets. So we called him up and said, how do you feel about getting a vacation that won't be relaxing or fun out to the United States and bring a robot and demonstrate it on the TV show? And he said, yeah, okay, we can figure that out. So the first thing he had to work out was, how do you bring like a 300-pound heavily armored mill droid to the United States at short notice? And the answer is, you take all the armor plate off and check it as luggage, and then you carry all the sensors on board. And when anyone from the TSA asks, you don't say that it's for a heavily armored kill droid or mill droid. So yeah, they brought the whole thing on with them on the plane. And what was I going to say about this guy?
The LiDAR.
Yeah, so it's based on a Segway RMP platform. So this was a thing that Segway put out specifically for researchers and robot people to build robots out of. It has GPS, but they weren't really using it because they couldn't get into the GPS. Or at the time weren't models out there that were completely open and would give them access to everything they needed for generating their noise models. So the only sensor that's being used is this Zik LiDAR that gives you a single line of range, and it comes out of the front of the robot. It's also the only vulnerable spot on the robot. And it's like a little tiny slit, and the Marine snipers have tried to shoot it, and last time I went to visit him, there was a bullet wound right on the edge of that lip, and the Marine sniper was like, all right, if I can get that close to it and not break it, then you're probably okay. But the guys are going to have a shot at trying to shoot that sensor out. But what it meant is that when it sees a hill, if the hill is too steep, it interprets that as an obstacle because it's only got that line of laser range finding, which led to some pretty significant challenges delivering pizza in the streets of San Francisco. Yeah,
but it worked out great. It actually worked in the city, and we were happy to get pizza delivered to us. So then, real quickly, we had the autonomous vehicle as well, and this was a project that was run by a friend of ours, Anthony Lewandowski, who it turns out was working at Google on another project, and but he was just doing this on the side, so he came over and used his car and helped drove over the Bay Bridge. It was actually the first rolling roadblock, the first bridge closing of an autonomous vehicle, or first bridge crossing. It was totally cool, and it turns out that the guys from Google had seen this on TV and said, Anthony, we want you to do this for Google, and paid him a lot of money, and now he's doing the self-driving car for Google, and he's probably the one that benefited the most from doing this show.
Really quick story about the rolling roadblock. You can see there, the police, they can't close the Bay Bridge, for just about anything, right? Because it's like such an important artery in San Francisco. So they said, we'll do this rolling roadblock. We'll basically just hold traffic back while you do this autonomous car crossing. And at the time, the car did not know anything about traffic lights. And the cop goes up to the producer, John Tessier, and said, there's traffic lights in between where you're starting at the marina and the bridge. What are you guys going to do about the traffic lights? And Tessier just said, we're just going to blast right through them. And, because he didn't know, dealing with the cops, you never really know. And the cop was just like, I thought as much. All right, let's do it. So big props
awesome
to the SFPD for that.
Yeah, it was a really cool experience. So, that's basically it. That was our experience on Prototype This.
One more in-joke that was too nerdy to make it to air. You can see here we've got our, playing with the pizzas, and every time we would take a pizza out of the pizza pie pack, or any of our testing of delivering the pizza and so on, Joe is an athlete. He gets hungry a lot. He would always take a slice of pizza out and eat it. And so we had this running joke that we wanted to get into the show about how pizza transmission is a lossy process, and there's parity errors, and every time you get it at the other end, there's a slice missing, but it was too nerdy and they didn't make it to air. But now you guys know it.
Yeah. And we ate a lot of pizza, man. I don't know how many pizzas we ate, but I think after this episode, I didn't touch a pizza for a few months. Yeah, it was, who thought you could get sick of pizza? Anyway, that's it. We are going to
QA room number 1, if you want to ask us questions. And the goons have kindly asked us to say that if you could leave through the side doors and not the back entry door, that would be much appreciated.
The ones that say exit. Yeah, awesome. All right, thank you guys.